Dear students, now we can continue with the autoregulation of the kidney. There are mainly two important mechanisms which is involved in the renal autoregulations. First one, myogenic response, and second one, tubuloglomerular feedback. What is myogenic response? Whenever the blood flow to the kidney increases, it stretches the elastic wall of the afferent arteriole. So as the blood supply to the kidney increases, it will dilate or stretches the wall of the afferent arterioles. So stretching the vessel's wall increases the flow of calcium ions from the extracellular fluid into the cells. So due to this stretching of blood vessels, the calcium ions from the extracellular fluids gets engulfed into the intravascular fluid, and the influx of the calcium ions leading into contraction of smooth muscles of afferent arterioles that causes constriction of afferent arterioles. So blood flow get decreased. അപ്പോൾ മയോജനിക് റെസ്പോൺസ് എന്ന് പറഞ്ഞാൽ കിഡ്നിയിലേക്കുള്ള ബ്ലഡ് ഫ്ലോ കൂടുമ്പോൾ ഈ afferent arterioles ആണല്ലോ ബ്ലഡ് സപ്ലൈ കൊടുക്കുന്നത്. സോ അത് ഡൈലേറ്റ് ചെയ്യും, അപ്പോൾ സ്ട്രെച്ച് ചെയ്യും. അപ്പോൾ അതിൻ്റെ ഫലമായിട്ട് വെസൽ വോൾ സ്ട്രെച്ച് ചെയ്യുകയും പുറത്തുള്ള എക്സ്ട്രാ സെല്ലുലാർ ഫ്ലൂയിഡിൽ നിന്നുള്ള കാൽഷ്യം അയൺസ് ഇൻട്രാസെല്ലുലാർ ഫ്ലൂയിഡിലേക്ക്, അതായത് ഇൻട്രാവാസ്കുലർ ഫ്ലൂയിഡ് ഈ അഫറൻറ്റ് ആർട്ടീരിയോൾസിലേക്ക് കിടക്കുകയും ചെയ്യും. അപ്പോൾ എന്താണ് ഈ കാൽഷ്യത്തിൻ്റെ ഫങ്ഷൻ? എന്താണ്? കൺട്രാക്റ്റൈൽ ഫങ്ഷൻ. സോ ഈ അഫറൻറ്റ് ആർട്ടീരിയോളിനകത്തുള്ള സ്മൂത്ത് മസിൽ ഫൈബേഴ്സ് കൺട്രാക്ഷൻ ഉണ്ടാവും. സോ ഇറ്റ് കോസസ് എ കൺസ്ട്രിക്ഷൻ ഓഫ് ദ അഫറൻറ്റ് ആർട്ടീരിയോൾസ്. കൺസ്ട്രിക്ഷൻ ഉണ്ടാവുമ്പോൾ blood supply കുറയും. The next technique is tubuloglomerular feedback, which means macula densa plays an important role in tubuloglomerular feedback, which controls the renal blood flow and GFR. This macula densa having an important role in the tubuloglomerular feedback that controls the renal blood flow and GFR. Special features of renal circulation. What are the special features of renal circulation? Renal arteries arises directly from the aorta. So the high pressure in the aorta facilitates the high blood flow to the kidneys. Renal arteries are directly arising from the aorta. So if the pressure in the high aorta, that causes or that increases blood flow to the kidneys. Both the kidneys receive about 1300 ml of blood per minute, and which is about 26% of the cardiac output. Then kidneys are the second organs to receive maximum blood flow, the first organ being the liver. Okay, so the maximum blood is received by the liver and the second organ is the kidney. So the liver can receive about 1500 ml per minute. That is a 30% of the cardiac output. But the renal system is a little bit lower. It receives 26% of the cardiac output. The whole amount of blood which flows to the kidney has to pass through the glomerular capillaries before entering into the venous system that we have seen. And because of this, the blood is completely filtered at the renal glomeruli. So before entering to the venous system or the glomerular capillaries, the blood has to pass through all of the glomerular capillaries. So the filtration of all blood is completely done, okay, before it entering into the venous system. The renal circulation has a portal system, which means a double network of capillaries that we have already discussed, which all are the glomerular capillaries and peritubular capillaries. Hence it is known as portal system. Renal glomerular capillaries form high pressure bed with a pressure of 60 mm Hg to 70 mm of Hg. It is much greater than the capillary pressure elsewhere in the body. Okay, so the renal glomerular capillaries form high pressure bed with a pressure of 60 mm of Hg to 70 mm of Hg, and it is much greater than the capillary pressure elsewhere in the other part of the body. Then peritubular capillaries form a low pressure bed with a pressure of only 8 to 10 mm of Hg, and this will helps in the tubular reabsorption process. Autoregulation of the renal blood flow is well established. So this autoregulation of the renal blood flow is well established. Okay, so that's all regarding the renal blood flow. Then other portions we can discuss in the next class.